A very good afternoon, everyone. I'm Shweta Singh, your chemistry teacher, and I welcome all of you to Q&A session. So, how are you, Samagna, Shubhranshu? How are you all doing? Am I audible? Great. Okay. So, as you know, we are discussing states of matter and we are still continuing the same thing what we started. And if you remember in the last session, we actually discussed about the solid state, right? We discussed about the solid state. So we will continue this further. Hello, Mahadevan. Good afternoon. Okay, so let's have a recap first what we did in the last session. Okay, so we were discussing about the states of matter, and we said the states of matter are classified into solid, liquid, gas, and we have two more states, plasma and Bose-Einstein condensate. So this is something we discussed, right? After that, we talked about the solid state, that the spaces between the particles are least in solid state and the forces of attraction are maximum. The kinetic energy of particles is least when we compare solid, liquid, gas, and they are very closely packed. The particles are very closely packed. Coming to the properties, so we said they have definite shape, definite volume, and we said they are incompressible. But we took the example of sponge and we discussed also why do we say it is compressible. Okay, then it is they are rigid. Mostly they are rigid, but some are elastic, some are plastic in nature. So this is something we discussed in the last session. Okay, now for today's session, we should know about viscosity, compressibility, and fluidity. So we already discussed it in detail in the last session. Or do you want me to repeat any of them? Viscosity, compressibility, fluidity.
Repeat, ma'am.
All of all these three, Mahadevan, all these three,
Yes,
or
ma'am.
any one? Okay. So basically, I think you are attending the class for the first time for chemistry, right?
Yes, ma'am.
Okay, that's why. Fine. So viscosity, when we say how much thick it is, right? Like when we compare honey and water, we say honey is more viscous. Then because it can't flow easily. What is the reason behind it? So basically, when the liquid flows, no, when liquid flows, it flows in the form of layers. Okay, it flows in the form of layers. Just give me a second. Yeah. Just give me a second. I'm trying to. Okay. So the liquid flows in the form of layers. So these are the molecules of liquid. Here also we have molecules of liquid. In the next layer we have the another set of molecules. Now these molecules of different layers are having intermolecular forces of attraction between them, isn't it? Don't you agree, Mahadevan?
Yes, ma'am.
Okay, so if these intermolecular forces of attraction will be there, then what will happen? It won't allow it to slide easily. Like the layers, when they slide over each other, then the liquid flows. So when there will be strong intermolecular forces of attraction between the particles of different layers, it won't allow the layers to slide easily. It will create resistance. It will create internal friction in the movement, and the more we have this type of interaction, the more it is difficult it to flow. We call it a thick liquid or we call it a viscous liquid. Understood what is viscosity?
Yes, ma'am.
Okay, now coming to the compressibility. Compressibility means uh, the property by which a substance can be accommodated in less volume, like gases. The same amount of the gas can be accommodated in very less volume. But if you have sugar, if you have a container of sugar and you want to press it in half of the volume, it won't, because it is incompressible. Okay. And the next is fluidity. That's the property to flow. Am I clear?
Yes, ma'am.
Okay. Aditi, good afternoon. Okay, so these are the prerequisite before we start the next topic, and we are still doing the states of matter. As I said, it carries 1 to 3 marks. Now, in today's session, we are going to discuss about liquid state and the properties of liquid state, where we will discuss about viscosity is something we have already discussed. We will discuss about the vapor pressure and surface tension. The third was viscosity, which we already discussed. We understood what is viscosity. Okay, let's start now. Okay, so coming to the liquid state, now the spaces, the interparticle spaces between the particles, what will be there? It will be moderate, not as less as solid state and not as much as in gaseous state. So it will be moderate. Okay, then coming to the intermolecular forces of attraction, that will be less, not as strong as in solid state. Then kinetic energy of the particles will be moderate, not as low as in case of solid state, or not as high as in case of gases. So it will be moderate. So every property here of the particles, maybe it's interparticle space or interparticle forces of attraction or kinetic energy, they all will be moderate. On that basis, we can say that in liquids, particles have a moderate distance between them, so particles can move. So they have little spaces between them, so the particles can move easily. Okay, fine. So coming to the properties now, liquids have fixed volume but not shape. So basically, they take the shape of the container. The liquid take the shape of the container. They don't have their own fixed shape, but yes, they have fixed volume, right? If you fill this bottle with water and you want, no, instead of 1 liter, I want 1.5 liter water in this bottle. So you won't be able to compress it. You won't be able to change the volume of the water, right? So it has fixed volume. Okay, so liquids cannot be compressed easily. All liquids flow. The liquids have the property called fluidity. So one question for you: does only liquids have fluidity? Do only liquids have fluidity, or gases also?
I think gases also have fluidity.
Yes, gases also flow, right? So both, the fluidity is the property of both liquid as well as gas. Okay, fine. Now coming to different properties. I hope this much is clear to everyone. Clear now? So on the, we actually discussed what so far about the liquid state. First, we discussed the characteristics of the particles which are present in liquid. We said they don't have much interparticle space, but yes, it's more than solid. Okay, and due to those little spaces, the particles can move. Then we said interparticle forces of attraction, that's moderate, not as strong as in case of solid state, not as weak as in case of gaseous state. It's moderate. Again, coming to the kinetic energy of the particles, the solid state, the particles in solid state, they have very less kinetic energy, but in case of liquid state, it's moderate. Okay, on these basis, then we started discussing about the properties of liquid state, where first we said the liquids have definite volume but not fixed shape, right? Whereas the solids have both definite volume as well as shape. Okay, liquids cannot be compressed easily. Even solid cannot be compressed, right? So liquid also cannot be compressed. But liquid have a property which is not present in solid, that is fluidity. The liquid has the property called fluidity, means the liquids can flow. Okay. Now we will discuss about the different properties of liquid, right? Different properties of liquid, and this property, the first one is viscosity. For viscosity, we have a, experiment and activity here. Arrange four transparent containers. Let's arrange four transparent containers. And then we will take scales in slanting position like this. This is the activity given in NCERT itself. Okay. We will place the scales in slanting position. Now we will take four different types of liquids here: milk, honey, kerosene, and water. Okay. So as you can see, we got water, honey, milk, kerosene. Now you need to find, when you allow these liquids to flow down, okay, when you allow these liquids to flow down through the scale, observe the speed at which they come down. So first question here, what do you think which will come late? Which
Honey.
will be flowing with, sorry?
Honey.
Honey will come late, or the speed of the honey will be the slowest one. Okay, now the next question, which will be coming fastest? Which will be
Water.
coming down in the fastest speed? Sorry?
Water.
Water? Shubhranshu, Samagna, Aditi, what do you say? Is it water? Okay, so basically it's kerosene. Okay, so this is something tricky here. So the kerosene is the one which will be coming down first, followed by water, then milk, and then honey. Okay, so it means the water is more viscous than kerosene. Okay, so which one is having the least viscosity among these four? Least viscosity. Tell me, which one is least viscous? Exactly. Kerosene will be least viscous. Okay. Aditi, do remember which one will be most viscous, like which one will be having the highest viscosity? Which will be having the highest viscosity? Honey. Now the answer is honey. Okay, so basically whichever will be coming down fast, it means it is easier for it to flow. Why? Because it is less viscous, less friction, internal friction is present there, right? So kerosene is having the least viscosity, and honey will be having the highest viscosity. So the activity based question could be like this, as we just discussed now. Okay, fine. So this property is called viscosity. So less viscous liquid flow easily. Now coming to the next property, and the second property here we need to discuss is vapor pressure. This is something now going out of syllabus. Viscosity is given in your course, but vapor pressure is not given, but you should know. Okay. Now let's try to understand vapor pressure. Suppose I take a container here in which a volatile liquid is present. Volatile means it can vaporize, its molecule can vaporize, and I close it with a lid. So two processes will be occurring here simultaneously. One process, the liquid changing into vapor, right? And second process, vapor changing back into liquid. Okay. So both the processes occur simultaneously here. Okay, so some molecules of the liquid will be going into the vapor state, and some molecules from the vapor state will be coming back into the liquid state. So the process in which gas or rather liquid changes into gaseous state is called, this process is called, we need to study in this chapter itself, but I think you have done this before also in lower classes. When liquid changes into gaseous state, this process is called, okay, so let it called evaporation, fine. Okay. And when gas changes into liquid state, then what do we call it? No, we call it condensation. We call it condensation. Am I clear? Shubhranshu, Samagna, Shaktivel, Mahadevan, Aditi, clear? So the process of converting liquid into gaseous state, I'm calling it evaporation, and gases to liquid state, I'm calling it condensation. So both the processes are taking place simultaneously. Okay. Now, there will be a time, when the rate of evaporation, means the speed with which evaporation is occurring, will become equal to the rate of condensation. Have you understood this part? There will come a time when the speed of both evaporation as well as condensation both will become equal. So if you understood this line, please show me thumbs up. Aditi understood. Shubhranshu understood. Mahadevan also. Samagna and Shaktivel, I'm waiting answer from your side. Okay, Shaktivel also understood. Samagna, have you? The last line what I wrote? Okay, fine. So this movement, when both the rates become equal, we call it equilibrium condition, right? We call it equilibrium condition. Now at equilibrium, the amount of the molecules which were in vapor state, right? The amount of the vapor, or I should rather say the molecules, the number of molecules which were in vapor state now won't change. They will become constant. Right? Why? Because the rate of evaporation has become equal to rate of condensation. So as many molecules they were converting into the gaseous state, in the same manner they will be coming back into the other molecules will be coming into the liquid state. So overall, the number of molecules in the vapor state will remain constant. Am I clear? Is this line clear? Okay, so at this time, I'm going to say the container is now saturated with vapor. Why? Because now no more vapor will, no more increase in the vapor has seen. There will be no increase in the vapor after this. So I'm going to say that the container is now saturated with vapor. Is this line clear to everyone? I know this topic is little difficult to understand, but I'm taking it very slowly and making it easier. Yeah, you need to tell me, is this clear so far? When I said the container has become saturated with vapor? Mahadevan, it's clear. Yes. What about others? Aditi, Samagna, Shaktivel? Shaktivel, have you understood? Okay, fine. So now at this condition, when your container has become saturated with vapor, at this condition, whatever the pressure applied by these vapors on the surface of liquid, right? On the surface of liquid, whatever pressure is applied by the vapor is called vapor pressure. Understood? So that's the vapor pressure of a liquid. So whatever liquid we have taken in the container, it's the vapor pressure of that liquid. Okay, so vapor pressure is nothing but it's the pressure applied by the vapors of the liquid on its surface, on the surface of the liquid when it is in saturated condition. Am I clear what is vapor pressure? Is it clear to everyone? And if you have any doubt about vapor pressure, you can ask me right now. Have a look on whole of the process and then let me know. Is it clear or not? And if it is clear, please do write on the chat box. If it's clear, do write in the chat box and take your time, try to understand. Great, I got 3 yes. I'm waiting for one more. I think I didn't get answer from Shaktivel. Okay, fine. Okay, so we understood what is vapor pressure now. Now coming to the third property here. So these all topics means just now you did about the viscosity is something which is given in your NCRT. Vapor pressure is not given, surface tension is not given, but they are the properties of liquid, so you should know about them. Okay, fine. So let's try to understand what is surface tension. Okay, so when you take a liquid in a container, some of the molecules will be on the surface and other molecules of the liquid will be inside the container, right? So the molecules which will be inside the container will be experiencing forces of attraction, equal forces of attraction from all the direction because they are surrounded by other molecules, right? So completely surrounded by the other molecules. So they will be experiencing forces, equal forces of attraction from all the direction. And I'm going to say balanced forces of attraction, right? Balanced forces of attraction. Fine. But the molecules which are on the surface will be experiencing more force of attraction from downside because above them they are not actually completely surrounded by the uh, molecules of the liquid, right? So they will be having more force of attraction towards down as compared to upside, right? So I'm going to say that it is facing unbalanced forces of attraction, yes or no? More forces of attraction from downside, isn't it? So far, is it clear to everyone? What am I going to explain here? I explained so far that the molecules which are within the liquid, they are experiencing balanced forces of attraction, but which are on the surface, they are experiencing more force of attraction towards downside. Shaktivel, Mahadevan, is it clear?
Yes, ma'am.
Okay. Fine. So before we move ahead, you can see Google form is shared in the chat box. Please do not forget to fill it. So before leaving the class, do fill it. Okay. Okay. So now coming back to the surface tension. So what is happening here? The molecules which are at the surface, right? Molecules on the surface, they will be drawn in the liquid. They will be drawn in the liquid. And that's why we see the meniscus like this. This is meniscus. We don't see liquid like this. Actually, we see liquid like this. Okay, because of these imbalanced forces of attraction. So this imbalanced force of attraction is the reason behind surface tension, right? Is the reason behind surface tension. The molecules which are at the surface, they're experiencing unbalanced forces of attraction, due to which their energy rises and they become unstable, right? They become unstable, and that leads to the surface tension. So if I have to define what is surface tension, then what will I say? uh, just give me a second. Yeah. So if I draw, if this is the surface of liquid, right? If this is the surface of liquid and I draw a line over this surface, then per unit length, if I divide them in equal length, okay, so per unit length, the force which is acting perpendicular to this line is called surface tension, right? So what is surface tension? The force acting perpendicular to the line drawn on the surface of liquid per unit length, that is surface tension. So I'm repeating once again, what is surface tension? That is the force acting perpendicular to the line drawn on the surface of liquid per unit length. Am I clear what is surface tension? Clear? Okay. So surface tension is very important. Why in our daily life? Because surface tension is the reason why do we see the meniscus, right? Why do we see the meniscus in the liquid? And it can explain why are raindrops circular in shape. Actually, it's not circular in shape. Basically, what is the shape of the raindrop? It's like this. Okay, so what is happening here? As I said, the when we have more molecules on the surface. Now listen carefully. You need to tell me, have you understood this or not? So be attentive right now. When we have more molecules on the surface of liquid, it means they are going to suffer more surface tension. To avoid that surface tension, the molecules actually arrange themselves in a manner so that they have less surface area, right? They have less surface area. And that's why the raindrop which is falling, it is actually spherical in shape, right? It is actually spherical in shape because the sphere has lesser surface area as compared to flat or the plane, because here more molecules will be exposed or more molecules will be on the surface. But in circular, most of the molecules will be inside, only less number of molecules will be on the surface, right? But due to gravity, the raindrop takes this type of shape. Am I clear?
Yes,
Am I
ma'am.
clear? How is surface tension involved there? I'll tell you one more thing here. Whenever, mercury which is filled in the thermometer, and mercury is in liquid state. So whenever the thermometer breaks, the mercury, or I should rather say the mercury falls on the floor, it takes circular shape. Why? To avoid surface tension, to have minimum surface area. Yes, Mahadevan, tell me.
Nothing, ma'am.
Understood?
Yes, ma'am. Yes, ma'am. I just wanted.
Okay. Okay, so this is about surface tension. So let's conclude what we did today. We discussed about the liquid state. We discussed about the properties of liquid state. So can you help me to write down all the properties of liquid state? Yes, properties of liquid state. Tell me one by one. So first of all, I should write, what about its shape and volume? Come on, tell me. It's easy, no? Now, first, shape and volume. Let's start with shape and volume. So they have definite, definite shape or volume? Definite volume, but not shape. Okay. Are they is liquid compressible? Is liquid compressible? No. So liquid is incompressible. Fine. Then, do they have ability to flow? Do liquids have ability to flow? Yes. So fluidity also present there. Then now comes viscosity. Then viscosity. Then which other property did I tell you? Vapor pressure, right? Vapor pressure, and definitely surface tension. So these two are out of syllabus, but I gave you the idea what are these terms: vapor pressure and surface tension. You should have this in mind. Otherwise, whatever written at the top, they are actually given in the textbook. So you should know well about them. Okay. Fine. So what's next? In the next session, what are we going to discuss? We are going to discuss about the gaseous state. The way we discussed here about the liquid state, in which some of the things are out of syllabus, but there are some things we should know beforehand. So like this, we will be talking about the gas laws here. Okay. So any doubt so far? Any doubt related to liquid state and properties of liquid state? Any doubt, Mahadevan? No? So have you understood? So this was your first class and you started in middle of the chapter. I hope that was not issue, Mahadevan. Okay, so Samagna, Aditi, are you liking the classes? Is your summer course going well as you expected? Enjoying the classes? Great. Good to see. Oh, great. Thank you, Samagna. Thank you so much.